Today we'll be serving glass rendered in cycles. We'll start out with an appetizer of twisting the default cube seasoned with some smooth glow. And for our main course today, we have a round cube with a Voronoi displacement texture served on a locally produced spherical gradient. And for dessert, a sweet dynamic paint simulation with fun ripples for the whole family. And if you're still hungry after all this, we'll use a free and open source software to upscale our final render using machine learning. And this video is sponsored by NVIDIA and Scan. But more about that later. Okay, so before we start, I can recommend that you download the latest NVIDIA drivers because it might make your Blender setup a little bit more stable. So just fill in the GPU that you have and change it from game ready to studio driver. It just helps a little bit with the stability, you know. So here we are in Blender version 3.3, and we're going to start out by not deleting anything actually, because I want to turn this default cube into a glass material. So let's go to material properties, and under surface, let's change it from principled BSDF to glass. So let's set it to render view. Let's go to render properties and let's set our render engine to cycles. If you have an NVIDIA GPU, I can highly recommend that you go to edit, preferences, and you set your cycles render device to optics. This will speed up your rendering tremendously. But now I'm not super happy about this glass. We need to tweak this a little bit more. So let's go to material properties and let's change the roughness to 0. Here's where the magic happens. Refractions. Let's go Shift A and let's make a plane. Let's scale this up. Let's select our cube and let's press G and Z and move it so it's placed roughly on the ground. Now we can see that this is glass, but I think that this has a lot more potential because this doesn't really look like super cooled liquid, because that's what glass is. So let's just try and give this a more rounder shape. Let's go to modifier properties, add modifier, bevel, and then let's go add modifier subdivision surface. And now you can increase the levels viewport and the render. Let's do 4, for example, and then right click and set the shading to smooth. So now you can see we have a much smoother cube, which just starts making these beautiful refractions. Look at this. And then you can also use this bevel modifier, and then you can basically change how much of a cube you want this to be. Let me actually just compare this to the previous version. So all these refractions that are happening inside this cube is what we'll be trying to take advantage of in this tutorial. Now we already have a camera in our scene, so let's just position your viewport where you want to place the camera, and let's press Ctrl Alt Numpad 0. And then if you want to pan and tilt, you can press RR and then hold down Shift. Okay, so let's make this cube just a little bit more interesting. Let's go to add modifier, simple deform, and let's change this twist to Z. So now we can twist this on the Z axis, and then you can right click, set origin to 3D cursor. So now our cube is twisting like this. Beautiful. Now the colors are a little bit washed out. So let's go to world properties and change our background strength to 0. Now we're still rendering everything outside of here. So let's just press Ctrl B and let's just box select outside of this, and we'll only be rendering our camera view. So let's render this out as a still image. Let's go to render properties, set our max samples to something much lower. Let's do 256. And to render this, let's go render, render image. Okay, so this was a 5 seconds render, but let's have a closer look. Now if we zoom in, you can see that we have these low poly edges here, which I want this to be really smooth. So let's render a new version, but before we do that, we want to change our render slot from 1 to 2. Now we can select our cube, let's go to modify properties, and let's increase our subdivision surface level for the render from 4 to, for example, 6. So now let's do another render, and that was, oh, it's still under 5 seconds. It's even faster actually. And now you can toggle between these two renders using 1 and 2. And look at this. Look at how much smoother the render is in the second one. So here it was before, you can especially see it here. And here's the second one. You get all these really round and smooth refractions inside of this, which just looks really cool. Now, there is one problem here that you really can't see unless you're rendering this as an animation, and that is the noise threshold of our render. Let me increase the exposure so you can see what I mean. Under render properties, let me just increase the exposure. Let's set it to 4, and then let's disable noise threshold. So this is without noise threshold, and this is with. Look at that. The noise threshold just prevents the light from bouncing around inside our glass. And this isn't really that noticeable in a still image. You know, I had to increase the exposure by a lot and I had to just really zoom in. But on a video, this is going to create a lot of noise in your render. So I can highly recommend when working with glass animations to turn off the noise threshold. So one more thing that I want to fix is you see this really hard edge here. I want this to be really smooth, and that can actually be fixed quite easily because this edge is actually the refraction of the ground. So let's select our ground plane and let's just press S and let's scale this up. Now we have an 800 meter large plane, and you can see we have this really smooth edge here, which looks a little bit better. Let's render a new version, render slot 4. Now, I think the contrast is a little bit high for this. So let's just add a simple glare node to make this look a little bit less harsh. So let's go to compositing and let's go use nodes, and let's simply go Shift A filter glare. And I want to just place this in between the render layer and the composite. And I want to change it from streaks to fog glow. I want to change it from medium to high. And I want to change the mix from 0 to minus 0.95. And I want to change the threshold to 0 and the size to 9. And those are the settings that I recommend just to use as a simple glare. Now, if you just press tab, it will be composited onto the render. So now you can press F11 again. And here you can see we have a little bit of a glare. But now a little problem here is that this light source is really sharp, so it creates this speck of light. I don't really like that. I want a smoother light source. So let's go back to layout, scroll to zoom out and see our light. And let's go to the object data properties and let's just increase the radius of our light to 1 meter. So now we have a much smoother light source. Let's go F12 and let's look at our final render. That is a 7-second render and I think this is looking really cool. So that is the simple twisting cube. Let's have a look at some displacement texture. Now we want to save our work, so let's press Ctrl S and let's just call this Glass version 1. And now what's really cool is that we have this compositing setup, we have our glass material setup, we have certain elements in this scene that we want to carry over to the next one. So a really nice way to just bring that data over to a new project file is to go File, and instead of Save, we'll use Save As. So now we can simply use our numpad button to just press plus, and it will create Glass version 2. Now you can see we're in the version 2 file and our version 1 is perfectly fine. So let's turn this cube into a sphere and then let's give that sphere some displacement texture. This looks really smooth, by the way. I really like this look. To make this into a sphere, let's just go to modify properties. Let's get rid of the bevel. Let's actually just delete it. And let's make a cube. And let's move it on the z-axis so it's placed in the center like this. And let's go tab to edit mode, right click, subdivide, and let's set the number of cuts to 10. And then also let's increase the smoothness to 1. So now we have something that looks a little bit like a sphere. Now let's press tab to go back to object mode and let's move this up a little bit. Let's go to material properties and let's just give this our material. Let's actually rename this glass so it's a little bit easier to see. So now you can select our sphere, right click, shade smooth, and we have a really smooth sphere. Okay, nice. Let's give this some displacement. Let's go to modify properties, add modifier, displace. And then you can simply click new texture. To access this texture menu, you can click this little icon here called show texture in tab, which is the same as going down here. Okay, so let's change our displace texture type from image to Voronoi. So this looks really weird right away. And that's because we don't have enough geometry to make this look smooth. It's just not enough data here. So let's go to modify properties, add modifier, subdivision surface, and no matter how many levels we add to this, it just becomes a blob. That's because the subdivision surface modifier is calculated after the displace modifier. So let's just click and drag and move it before. Okay, it still looks crazy. So let's tweak this a little bit more. Texture properties. Let's actually disable this preview because that's a little bit annoying, I think. Now you can hold down shift and you can increase the size. And now you can see we are getting a beautiful texture here. And now this might not be really useful to be in render view right now, although you can try and use the viewport denoiser, which is quite fast and really efficient actually, using the optics with the NVIDIA card, which is really nice. But for now, I just want to be in solid view. Here we can see our Voronoi texture is displacing our round cube. But there are some settings here that can be tweaked to make this look a little bit more interesting, if you ask me. So let's go back to the texture properties and let's change the distance from actual distance to Minkowski 4. I just think this looks a little bit cool. You'll see you get this little bit of a schwung here, and yeah, I really like this look. Instead of having the coloring set to intensity, I like position, outline, and intensity. But now the problem is, if we go to modify properties and just increase the levels viewport here, this just never gets really sharp. It has these edges that just goes bum, 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 like that. So what we have to do, we have to use a smooth modifier. So let's go to add modifier, smooth. It doesn't really do anything right away. So let's try and increase the factor. Let's set it to 2, for example. Okay, we're getting somewhere. And let's repeat this 3 times. But now what I found to also work is to add another subdivision surface modifier after the smooth modifier. So let's go add modifier, subdivision surface. Now this might really start to slow down your viewport. So I can recommend that you just lower the levels viewport to 0. Now we are getting a really interesting shape. So let's have a look at this in the render view. Look at that. This just looks so cool. So this is the part where you can just tweak stuff and go crazy, because this is a really cool effect, I think. I want to add a gradient texture to this, because we have a beautiful gradient texture here on the ground, but that actually takes quite a while to render because the light is bouncing from the light into the ground, into this glass blob, and then a bunch of ways inside this glass, right? But if we instead make a gradient emission texture, it will only emit from that into the glass, and it will speed up your render time significantly. So let me just show you a really smooth way to set up a smooth gradient texture in Blender. So let's select our ground plane. You can press Alt S to reset the scale, and let's scale it up a little bit, and let's move it behind on the x-axis. Let's rotate it on the y-axis by 90 degrees. Now let's view this from the camera again. Oh, we have to move our camera further back. So let's select our camera, G, and then Z 2 times. Okay, so now we're going to scale up our plane. Oh, look at how beautiful that looks already. So now we want to add a gradient texture to this plane. So let's go right click, vertical split, and let's set this editor type to shader editor. Let's select our plane and click new. And let's just call this gradient. And now for this to work, you need to have the Node Wrangler add-on installed. So let's go to add-on and just type Node Wrangler. Select the principled BSDF and press Shift S to just change this to texture gradient texture. So now the gradient texture just goes straight into the surface, which just works fine. And it's currently a linear texture. So let's change it from linear to quadratic sphere. And let's press Ctrl T. So now we have a texture coordinate node, and you can hold down Control and change this to object. So this is all you need to make a gradient background. But I just want to make this a little bit smoother. Shift A, converter, map range, and let's place this in between, and nothing changes because this is still set to linear, but we can actually set this to smooth step, or even smoother, which is called smoother step. So now we have a really smooth gradient background, which it really helps. So let me collapse this, right click and join areas, click on the one you want to remove, and now we have this beautiful gradient texture, and you can press S and scale it on the Z axis or on the Y axis, for example. It just makes this glass look so good, if you ask me. Okay, so this is looking cool, but I want to make an area light instead. So let's go X to delete the light and go Shift A, and let's make a light area. Let's move this on the Z axis, right click, increase the size, right click, increase the power. Look at this, you got these really interesting highlights that's coming from this light. That is looking really smooth actually. Okay, so now I want to animate this glass object into a little bit of a liquid effect, which I think looks really cool. So let's go to modifier properties, and under coordinates, you can see it's set to local for our displacement texture. So if I select this and move it around by pressing G, it's just nothing really happens. So let's select our glass object. Let's go Shift S and let's go cursor to selected, and let's go Shift A and let's make an empty object. If you like, you can right click and adjust the empty size so you can see it a little bit better. Let's rename this empty object by pressing F2, displacement controller. Let's go back to the glass object and let's set our coordinates from local to object, and let's set the object to be displacement controller. So now this is really cool. Now we can select our glass object, we can press G and we can move this around, and it will animate like this. Let me just show you what it looks like in solid view. Look at that. Look at how cool this effect is. I really like this. So now let's give this some animation. So let's right click and let's go vertical split, and let's change this editor type to graph editor. Let's press N to get rid of that panel. So now we're going to animate this by recording our keyframes. So let's select our glass object and let's turn on auto keying. Let's press space to start the animation, and then let's press G. So now we can just move this around, and you can see on my right hand side that we are creating some keyframes. So now what we just did is that we just recorded our motion. Look at that. But now what I want to do is I want to make this a little bit smoother. So let's go to the first frame and let's go I and insert available. And then let's go to the last frame, which is 250. Let's take the first frame and let's go Shift D and X. And then let's just copy this to the last frame. So now it will loop. Let's go A to select all the keyframes. Let's go key, sample keyframes. And then to smooth these keyframes, let's go key, smooth keys. Now you can just press smooth keys a couple of times, maybe 2 times. And remember to turn off auto keying. So now when you press play, it's moving around like this smooth thing. It seems to starting on frame 60. So let's actually just delete all the keyframes before frame 60. Just select all of them, press X, and then delete keyframes. So now let's select all these keyframes, press G and X, and let's just move it to the beginning of the animation. Now, here's the cool part. Remember the empty object that we made? We want to copy the animation from our glass object to the displacement controller. So let's select our glass object, A to select all, and then Control C to copy keyframes. Select the displacement controller, and let's go I to insert keyframes, and then select location. So now we have these location keyframes here, and now you can press Ctrl V to paste the animation. You might be wondering, Why did we do that? We have just cancelled out this effect because they are moving synchronized, you know? Here's the magic. We're going to offset the movement of the displacement controller by just a few frames. So select the displacement controller and press G and then 4. Now you offset it by 4 frames. Let me actually just increase the levels viewport again so you can see how cool this looks. Now let's have a look. See that? It's like this wobbling glass effect. It's difficult to explain what's going on, and it will be difficult to sort of plan how this would look, but I just think it's really cool. And then on frame 190, you can set the end frame to be that. No, of course, it will be frame 194, since we added 4 frames. So now it's a perfect loop. Okay, so that is the displacement effect tutorial. Now let me tell you something that happened a few weeks ago. NVIDIA and Scan Computers reached out to me and they said, hey, we would like to sponsor you with an RTX 3090, and we would like to just build a really powerful computer around that really powerful GPU. And I'm like, that sounds amazing. Let's do it. So fast forward to a couple of days ago, they messaged me again and they said, hey, did you get it? Did you get the new computer? I'm like, computer? New? I didn't get a new computer. I got a new friend. You know, if you'd had told me that you can just put together a bunch of different computer parts and it becomes more than just the parts itself, I wouldn't believe you. But there it was, standing outside my office, ready for work. It told me it's actually from an award-winning PC range called 3XS made by Scan Computers, link in description. And it's got RTX Studio validated hardware by NVIDIA. But I couldn't help feeling that this thing is more than just a computer, because it remembers me. It's like its memory is just perfect. I learned about its brothers and sisters, the NVIDIA Studio validated laptops and PCs and other RTX GPUs. But this machine that came knocking on my door just a few days ago, it works and just works. It never gets tired, it never sleeps, it never eats. I'm told it's more machine than man, yet it's more man than I'll ever be. Okay, so that was probably a little bit... Let's just get back to the tutorial. So let's just go Control-Shift-S to save this as another version, which is version 3. So this is the dessert. We're going to make a fake fluid simulation using some dynamic paint and just create some beautiful ripples in this round cube object. We want to use our current setup with the lighting and the camera, but let's get rid of this glass object. And we can also get rid of this displacement controller. And let's go Shift A, let's make a cube. And we want to give this a glass material, so material properties, glass. Let's give it the bevel treatment and the subdivision surface treatment. Oh, look at this. This lighting setup is really cool. Let's select our camera and let's actually just move this in a little bit. Okay, oh, this is looking really good. Let's actually rename this cube to canvas. So this round cube is going to be our canvas with this dynamic paint effect. So let's go to modifier properties, add modifier, dynamic paint. Let's jump to the correct tab by pressing this little button. So now let's just click add canvas. So nothing really happened, but that's because we're going to have to make a brush that can draw on this surface. Let's go Shift A, let's make an icosphere. Let's move it on the Z axis. I want to press tab and go to edit mode. Let's scale it down a little bit and let's right click, subdivide. Let's set it to smoothness 1 and let's actually set the number of cuts to 2. So now if we go back to object mode, right click, set the shading to smooth, we have a sphere that is resting on top of our canvas. Let's turn this sphere into a brush. So under physics properties, we can just click dynamic paint and then we can set the type from canvas to brush and then just click add brush. So now if we select our canvas, let's just scroll down to surface type and change this from paint to waves. So now we can take our brush, let's actually press F2 and rename this brush. And now let's move this a little bit down. And look at that. If we hide this now, you can see that we are making a dent. So now what you can do is you can press space, then you can press G and then Shift Z to move it on all axes except for the Z axis. Look at that. And now we actually want to increase our animation duration here. So let's set it to 400 frames. Make sure you set the frame end to 400 in the canvas settings as well. So now we want to make this sphere rotate around like this to make these beautiful ripples in the water. Let's select our sphere. Let's press tab to go to edit mode and let's move it on the Y axis by pressing G and Y. And let's move it over here. And the reason why we're doing this in edit mode is because now when you go back to object mode, you can press R and rotate this on the Z axis and it will rotate around this point. So now let's go I to bring up the keyframe menu. Let's go rotation. Let's move 50 frames, and let's press R, Z, and then just move this like one round or something. It doesn't have to be super precise. And now let's press I and then insert another rotation keyframe. So now let's go back to the beginning of the animation. And now when you press play, it goes really fast. To make this go slower and in a smooth motion, hold your mouse down here and go Shift E and then go linear extrapolation. So now this will just keep going forever. And what's just so cool is that this ripple effect just continues down the edge here, which I just think this looks really cool. It might actually go a little bit too fast, so you can select the brush or the sphere object and just click and drag and select one keyframe, press G, and let's move it over here, for example. So now when you press play, it moves a little bit slower. Okay, let's view this from the camera view. Let's set it to rendered view. Oh, this is looking really cool. Let's select our sphere. Let's go to material properties, and let's also give this the glass material. Amazing. I think this is looking really cool. And then now you can start experimenting with the level of detail of your mesh, because it will change the simulation. So if you go to modify properties, you can, for example, increase the subdivisions from 5 to 6, and now it will look a little bit different. And now here's the really cool part. If you select the gradient background, now you can really start scaling this down, moving it up and down. Look how cool this looks. The scene just changes completely when you start tweaking this background light. Look at that. Let's just do a still render, F12. I didn't actually even realize that I had enabled motion blur. It's one of those things that just works in real time, almost, with the RTX 30 series. Okay, so yeah, oh, look at how cool it looks when these ripples are just going down the edges here. If you want to render this as an animation, I highly recommend that you go down to physics properties and you scroll down to cache, and then you just click bake. So it will bake and just save the entire simulation, which just makes for a more reliable render. If you zoom in and you see that you have these lines that you want them to be even smoother, you can go to modify properties, and then you can actually add another subdivision surface modifier after the simulation. Look at that. Let's do one more, which is crazy. Yeah, oh look, it gets really smooth. Let's actually try and do 2. I wonder how much this impacts render performance. Let's just see. Oh, yeah, it actually rendered faster. And then if you like, you can add some depth of field where the depth of field is following the ball. Also, one thing that is really cool is that this background doesn't have to be a gradient texture. You could have like a video texture that will be refracted inside this sphere and inside all of these type of warps and details. It's just such a cool effect. Okay, so rendering detailed glass like this in cycles can take a really long time. But after some experimenting, what I've noticed is that some of these hard yet organic shapes in our renders are responding surprisingly well to AI upscaling. So what we can do to reduce our render times significantly is to render our glass animations in a lower resolution and then use machine learning to upscale it to its original resolution. And of course, there is a free and open source solution to this problem. What a time to be alive. So the software that we are going to use is called Chainer. You just search for Chainer like this and then go to GitHub. It's a really powerful node-based software. It's amazing. It's open source. I love it. Let's go to releases. Oh, new version 12 days ago. Amazing. Okay, so under assets here, I'm on Windows. So I'm Chainer Windows x64. I'm just going to extract this to my desktop and let's open this. Chainer.exe. So here it is. Now, this is a really powerful node-based program and it supports PNG images, for example. So actually, let's get back to Blender and let's render one of the animations that we did as a PNG sequence. I want to render 80 frames. Let's set the file format to PNG. It should be PNG by default, by the way. And let's just create a folder on the desktop called Sequence Glass version 2 Sequence. Here's the deal. Instead of rendering this at 100% resolution, let's render it at 50% resolution, which is only 1/4 of the pixels. So look at that, that's under 3-second render. So let's render this as a PNG sequence, render animation. Okay, so while this is rendering in cycles, let's just go back to Chainer and start preparing our node setup. So here you can see we have a completely empty canvas. So we can, for example, load an image like this, and then we can go, I wanna invert the colors in this image, and I wanna save the image. Image to image, invert color, and then to save image. And what's really good about this program is that it's good at telling you what you need to do. So here you can see you have this red exclamation mark, missing required input data. Under load image, let's select the file. Let's just select the first image, open. And now you can see we have the image there. It's going to have its color inverted, and the image is going to be saved. Now we can see, oh, we have to set a base directory. So let's just set this to desktop. And now we need an image name. So instead of writing one, you can actually just take this one and drag the image name over. So now we can just click run. and you can see it completed the process in like 0.001 seconds. So now on our desktop, we can see that we have an inverted version of our image. But now here is the real power of this software. We can use it to upscale images using machine learning. Instead of just applying this effect to one image, we want to do it to the entire image sequence. So let's get rid of the load image and let's get rid of the save image and let's load a image file iterator. So this is basically a node setup that just runs over and over again until there are no more images left to process. Let's select our directory for the image file iterator and let's set it to our sequence folder. So now all our images will come from this node. You can actually just click and drag and get this menu, and let's go save image. Let's go select a directory. I want to make a new folder and call this upscaled. We want to add an upscaler to this, but there are some stuff that you have to download, but luckily for us, it's really easy to do that, because when I scroll down here and you can see PyTorch, it just says not installed. So just click install, and then you can see you have CUDA support, and then you can just click install. So now it's installing something that you need to just do this with your GPU. And then if you have other GPUs, I think you have to use these other formats. I did this on my other PC and it actually took something like 10 minutes or something, but you only have to do this once. Okay, so it's finished and you can actually hover over and see what this does. So it's going to take advantage of our CUDA GPU, which is nice because I have an NVIDIA GPU. And now I'm going to just press restart chainer. Okay, so now we got the PyTorch installed and you can scroll down, you can see that we have all these kind of things and we want to use upscale image. So now let's go to the image file iterator again, and then you can just place this upscale image inside the iterator. So now what we can do is we can take the upscaled image and we can go save image, and then we can take our loaded image into the upscaler. Let's select the directory. Let's go to desktop and set it to sequence, and let's go to save image base directory and let's set this to the folder called upscaled. We will load our image and it will get upscaled using machine learning and it will be saved as an image. There's a problem. We don't have a model. Look at this. If we just open this up and we go PyTorch load model, you need a pre-trained model. So this is a file, I think it's a PTH file, and these can be a little bit difficult to find actually in a good quality. So there's a website called upscale.wiki, and in the model database there are a lot of different models that have been trained to do upscaling. But I don't really like any of these. The only model that I have found that just looks really nice is one that is found in another software, which is called Upscale. This is also on GitHub. Here you can see it's an image upscaling graphical user interface. But what's really cool about this, if you go to release and you scroll down to Upscale, let's download this. Okay, so let me just extract this to my desktop. So we downloaded another upscaling software called Upscale, but instead of starting this software, let's go to Upscale data. And under models, ESRGAN, this one. This is the one you want. Real SR DF2K JPEG.pth. This is really good. So let's just copy this and then just paste it to my desktop. So now when we're back in Chainer, let's just set the model file to be this .pth file. Okay, so now we can press run. And you can see that this node network is working. Let's go to our desktop, and in Upscaled, you can see that this folder is being populated by these upscaled renders. Oh, it's just really cool to see. Look at that. I really like this. It's just so good. And then Chainer is such a good software to just have this inside of. So that is finished. Let's have a look at the render. I am using DJV to preview this with. Look at that. So this went from half HD, like 50% HD, to 4K. So I have actually made an overview of when you should render in 4K in cycles. So here you can see that it's close, but never is the largest part of the diagram here. So what's so cool about this is that Blender is free and open source, Chainer is free and open source, and the model is available through Upscale on GitHub, and I'm previewing this in DJV, which is open source. Life is good, you know? Okay, so that's it. Please enjoy the final results rendered at a low resolution and then upscaled using Chainer and amazing machine learning technology. make sure you check out Scan and NVIDIA in the description. They're making this really powerful 3XS computer setup, which I'm currently working on. This is by far the most powerful computer I've ever owned and ever worked on. It's amazing. And big thanks to them for sponsoring this video. And big thanks to you for watching.